Okay, welcome to video number 7 on our most accurate clock on Earth. Today's experiment is a little bit more investigation into our node bias that I have talked about in many experiments before. Now with our new pendulum we have got 4 launch points, a blue, black, red and green. In number 5 we've seen it launch from the red launch position, and we've seen that the actual pendulum swung heavily to the counterclockwise direction, indicating what you would see on the southern hemisphere. Now what I've done is I've actually mapped the node bias of this actual bob, and I've come up with this rough drawing here. So if I was to launch anywhere along this red zone, I'll get a counterclockwise direction. Depending on where I launch, it'll actually travel in a proportionally faster or slower towards the counterclockwise direction. Say for example I was to launch here, it would be a very slow progression to the counterclockwise direction, and here quite fast. So if I was to launch in the green, anywhere in the green, so anywhere in this green section here, I will get a clockwise direction with the pendulum. Now, what I've also found was the sweet spot, the equilibrium point, which is this point here roughly. Ideally I would have a launch, my next pendulum, my next bob will have infinite launch positions, so I can launch exactly at the sweet spot and get the true straight position. Now unfortunately I haven't got a spot there. My green is just a little bit off the true spot, so it goes clockwise slightly. I just thought I'd show you this. Now the bit I didn't ever want to tell you about, I'll have to tell you this. It is a possibility that Foucault actually realised that by launching the bob anywhere in these zones, he will get the desired result and the progression rate he wanted. We have to say that. I didn't want to say it. I don't want to. I have to say it. He's a man who's dead, but I also will defend him, because he may have also realised that, and he didn't care, so he always picked the centre spot and gave him the true. He might have actually mapped each one of his bobs and realised that by this spot here, the equilibrium point, he'll get a true straight. In that case, the only other vector will be the Earth spinning vector coming at this angle here. So that's basically where we're up to today. Possibly quickly show you the bob a little bit more. More advancement with this bob. It's we've gone to this white colour, and we've got a more accurate with the laser. So to pick this clockwise, anti-clockwise direction, if the bob is travelling, if it starts travelling with the line is more on the red side, going away, and more on the green side coming towards, that means it's going counterclockwise. If the other way, if it's going towards this direction on the greens on this side, and more on coming back on this side, it's going clockwise. So that's a pretty good indication. Now the other thing I would like you to notice is, oh dear, here we go, the incredibly frictionless point. This is almost zero friction. This thing has got no friction, this bob. Unbelievable. There's nothing. If Cavendish was to use this fibre optic glass for his experiment, he would have been ecstatic, because that is actually a true frictionless, almost zero frictionless, I don't know, I guess pivot point. Alright, let's get on to the experiment now. So here we go. Alright, here we go. First launch. Oh dear, we got a slight twist. That shouldn't have happened. I think I disturbed the... We should not have got that turn on our bob. I think that was turning that... I put a little bit of tension in the optical fibre. Maybe it'll be okay. I'll just kill the lights so we can just see a bit better. That line, what it's doing. But basically it's coming back to zero again. That's good to see. As you know, I do not like to see that swing on launch. Oh, I'm sorry about that. That was playing with that bob. I shouldn't have done that. It takes hours for this thing to settle down. Next bob will have a lot more. It's going more accurate again. The next bob. So we're still in the centre position. Okay. I think I'm detecting. I'll just zoom in a bit. I think there's a slight line, or the laser seems to be on the... No, maybe I'm wrong. Okay. Yeah, okay, I think the laser is certainly a little tiny bit on the right hand side going away from us, and slightly on the left hand side coming towards us. Yeah, maybe. As I said, I couldn't quite get this exactly in the sweet spot, so it is slightly going a little tiny bit clockwise. I often thought that would be a very handy metric to have, a slight bias on the clockwise to measure the rotation of the Earth. So again, in defence of Foucault, that would have been a very intelligent move to have a slight bias against the Earth, so that way you would know for sure that the vector coming that would turn the bob would be coming from the Earth. So again, in defence of Foucault, I know the man is not alive and he had left no notes, so we all have to just guess. Anyway, I think that's enough. This bob will just keep going straight. There's no use wasting your time. But I thought I would introduce you to this concept. Yes, it's certainly going away from us. It's on the right, coming back to us on the left. So there's There's a slight bias. Now obviously if the Earth was to overcome that, then we'd certainly have, and it was to direct it the other way, we would definitely know that the Earth was spinning, and enough to actually overcome that slight bias. Another avenue to investigate. Going away, coming back, going away, coming back. What I'll do is I'll stop the video now and I'll just come back and you might see the dying moments. That might be of interest. So here we are about 5 minutes later. Clearly going away on the right, coming back on the left, which is clockwise. Now I just stopped, I just introduced this point here because I want to show you that the actual green and its opposite black indicators actually tracking true. They're actually following the laser, although the bob is going clockwise. Now there's something to think of. Again, in defence of Foucault, this is what he expected, that a vector, that a mass travelling in a certain direction will maintain that and overcome anything else. So that's, yes, that's showing that it's actually going. I did come across this before where I didn't want to. Alright, yeah, okay, so the bob is going clockwise, rotating clockwise, but yet the two green and black indicators are going straight along the laser. Yeah, okay. Interesting for you people building clocks. Your bobs or your pendulums should be doing the same thing. Alright, I'll stop it again now just to get the dying moments. So here we are back again. It's about 20 minutes. Clear the bob is still travelling clockwise, so during that 20-minute period the Earth's rotation wasn't strong enough to overcome that slight clockwise bias, but nevertheless. So the interesting thing was that swinging motion corrected the pendulum, so now it's running true, so remove that swing out of it, which is another vector I didn't think of. So there you go, just by observing experiment differently and making a slight mistake, you actually get a really positive result. Alright, so I think that's enough. So hopefully the next bob I make will be able to be launched from any direction. It'll be more accurate again, and I'll have that ability to just tweak a slight clockwise, very slight, precise, measurable clockwise bias, so that way we know if the Earth was to spin and overcome that slight clockwise bias and switch it to the counterclockwise bias, we'll definitely know that the Earth is spinning. So okay, I don't know how long it's going to take me to make this next bob. They're not easy to make, so stay tuned, and thanks for watching.